Imagine a bustling city, alive with activity. People going about their daily routines, cars honking and the hum of urban life filling the air. Suddenly, without warning, the ground begins to tremble. A low rumble grows louder, shaking the very foundation of the city. Buildings sway precariously, windows shatter into countless shards, and the earth seems to roll like waves beneath your feet. The once stable ground now feels like a turbulent sea. This is the terrifying reality of an earthquake, a powerful natural phenomenon that can transform a familiar landscape into a scene of chaos and destruction in a matter of seconds. Streets crack open, buildings crumble, and panic ensues. Earthquakes remind us of the immense forces at work beneath the Earth's surface. The movement of tectonic plates, unseen and unstoppable, holds the power to reshape our world. The aftermath of an earthquake is often a stark reminder of nature's power. The once vibrant city now lies in ruins, a testament to the sheer force of the quake. Rescue workers search frantically through rubble, while survivors grapple with shock and loss. The community comes together, united in the face of disaster, to help those in need. The once familiar streets are now littered with debris, and the air is thick with dust and the smell of smoke. The cityscape is unrecognizable, transformed by the quake's fury. The impact of an earthquake extends far beyond the immediate physical damage. It affects the infrastructure, the economy, and the very fabric of the community. It disrupts lives, communities, and economies, leaving lasting scars on the affected regions. Families are displaced, businesses are destroyed, and the road to recovery is long and arduous. Beneath the Earth's surface lies a dynamic layer of massive, moving plates called tectonic plates. These plates are in constant motion, albeit extremely slow, driven by the heat emanating from the Earth's core. As these plates collide, grind against each other, or slide past one another, immense pressure builds up along their edges, known as fault lines. When the stress exceeds the strength of the rocks, a sudden release of energy occurs, sending shock waves through the Earth. This release of energy is what we experience as an earthquake. The point where the rupture occurs deep underground is called the focus or hypocenter. The point directly above it on the Earth's surface is called the epicenter, and this is where the shaking is usually felt most strongly. Scientists use sophisticated instruments called seismographs to detect and measure earthquakes. Seismographs record the vibrations caused by seismic waves, which are the energy waves that travel through the Earth during an earthquake. There are two main types of seismic waves: P waves or primary waves, which are faster and travel through solids and liquids, and S waves or secondary waves, which are slower and travel only through solids. By analyzing the arrival times of these waves at different seismograph stations, scientists can pinpoint the location and magnitude of an earthquake. The Richter scale, a logarithmic scale, is commonly used to measure the magnitude of an earthquake, which represents the energy released. Each whole number increase on the Richter scale represents a 10-fold increase in amplitude and a 32-fold increase in energy release. The earthquake's aftermath, from destruction to disruption. The impact of an earthquake can be devastating, ranging from minor tremors to catastrophic events causing widespread damage. Ground shaking can cause buildings, bridges, and other structures to collapse, leading to significant casualties and economic losses. Earthquakes can also trigger secondary hazards such as landslides, tsunamis, and liquefaction, where the ground behaves like a liquid due to the shaking. The human toll of earthquakes can be immense, with loss of life, injuries, and displacement. The aftermath of an earthquake often requires massive rescue and relief efforts, with communities coming together to rebuild and recover. The psychological impact of earthquakes can also be significant, with survivors experiencing trauma, anxiety, and post-traumatic stress disorder. Preparedness is key steps to ensure safety. While we cannot prevent earthquakes, we can take steps to mitigate their impact and protect ourselves and our loved ones. Understanding the risks and being prepared can make a significant difference in how we respond when an earthquake strikes. One of the most crucial aspects of earthquake preparedness is having a plan in place. This plan should be discussed and practiced regularly with all family members to ensure everyone knows what to do. This plan should include identifying safe spots in each room of your home, such as under sturdy furniture or against interior walls, away from windows, mirrors, and heavy objects that could fall. Practicing drop, cover, and hold-on drills can also help reinforce these safety measures. Securing heavy furniture and appliances to prevent them from toppling over during an earthquake is also essential for safety. This includes bolting bookcases, shelves, and large appliances to the walls to minimize the risk of injury. Stockpiling emergency supplies such as water, non-perishable food, a first aid kit, flashlights, and a battery-powered radio is crucial for post-earthquake survival. Ensure that these supplies are easily accessible and that everyone in the household knows where they are stored. Knowing how to shut off utilities, such as gas, water, and electricity, can also prevent further damage and hazards. Familiarize yourself with the locations of these shut-off points and practice turning them off safely. Early warnings and modern marvels. Advancements in technology have led to the development of earthquake early warning systems, which can provide valuable seconds to minutes of warning before the ground shaking arrives. These systems are becoming increasingly sophisticated, integrating with various digital platforms to ensure that alerts reach as many people as possible in the shortest amount of time. These systems work by detecting the P waves, which travel faster than the more destructive S waves. P waves are the initial, less damaging seismic waves that can be detected by sensors, providing a critical window of opportunity to act before the more powerful S waves arrive. While the warning time may be short, it can be crucial for taking immediate protective actions such as dropping, covering, and holding on, or seeking shelter in a designated safe spot. These few seconds can make a significant difference in reducing injuries and saving lives. These warnings can also automatically trigger safety measures in critical infrastructure, such as stopping trains, shutting down industrial processes, and opening fire station doors. This automation helps to prevent secondary disasters, such as train derailments or industrial accidents, which can occur during an earthquake. Scientists are also continually working on improving building codes and construction techniques to withstand earthquakes better. This ongoing research and development are essential for creating safer urban environments, especially in earthquake-prone regions. These advancements include using flexible materials, base isolation systems, and energy dissipation devices to minimize damage and save lives. By incorporating these technologies, modern buildings are better equipped to absorb and dissipate seismic energy, reducing the risk of catastrophic failure. Knowledge to action, building a safer future. Earthquakes are a stark reminder of our planet's dynamism and the importance of preparedness. By understanding the science behind earthquakes, how they are measured, and the potential risks they pose, we can make informed decisions to mitigate their impact effectively. By taking practical steps, such as securing our homes, developing emergency plans, and educating ourselves, and staying informed about earthquake safety, we can empower ourselves and our communities to be better prepared. Remember, knowledge is power, and in the face of natural disasters, it can be the key to saving lives and reducing harm. By turning our understanding of earthquakes into action, we can create a safer and more resilient future for ourselves and generations to come.